Right, in this video we're going to we're going to introduce subtraction. In the previous video we were just adding, we were just looking at positive signs in polynomial algebra. Now we're going to introduce negative terms, and so we're going to be looking at subtracting, say, a binomial from a trinomial, or vice versa. Let's look at it though to start with conventional numbers, so numbers with no variables, just with fixed terms. The numbers we had last time will give us a good example. So we had let's write it here, 451 for example, and if we subtracted 320, so last time we added, this time we'll subtract. If we subtracted 320 from 451, we wouldn't run into any difficulties at all using this column method here. So from right to left, 0 from 1, 1, 2 from 5, 3, 3 from 4, 1. The answer is 131. If we think about these as polynomial expressions, in other words just as shorthand, it's equally straightforward. So 451 is actually 4 tens, okay, but 10 squared. So that's your 400 plus your 5, 10, that's your x term, so to the power 1 if you like. And then it's got how many ones? We've got 1, 1. Okay, so that's expanded it to give it its full polynomial expression. If we do the same here, we've got 3 10 squares this time, plus 2 tens. I'll drop the 1 I don't need to the power 1 because that's just stays the same, and we have no 1s, so we'll just have, well, we could say 1 0 if you like. So that's what we've really got here, and these numbers here of course are shorthand. And all we've done then is, if we just underline this a bit, if we use the column method that we used here, we can go from left to right or right to left. Let's go from left to right. So we've got 3 of these 10 squareds from 4 10 squareds. So in other words, we've just got 10 squared. Let's call it 1 10 squared. We've got 2 10s and 5 10s. So 5, take away 2, we've just got 3 10s. And here we've got no zeros, so 1 0 if you like. It should be actually 0. I've got this around the wrong way, haven't I? Let's just correct that. Okay, so it should be 1s. These are 1s. So we've got 0 1s. So 0 1s from 1 1. We've just got 1. Let's just put 1 here. Keep it nice and straightforward. Okay, and so we've got exactly the same as we had here. We've got 100, because that's what 10 squared is. We've got 3 10s, that's 30. And we've got the 1, so 131. Now, this is when x equals 10, of course, so x equals 10. So you could just replace all these 10s with x and you'd see the polynomial. Now let's just write down the other 2 numbers that we had in the last video. So we had 201 and 13. This is when we ran into we would run into borrowing, and this is really what I wanted to show you. So 3 from 1 we would say doesn't go, okay, if we're using the standard algorithm. So we would have to borrow all the way from over here, so that becomes just 100. The 0 here now, if we say, well, we've now got 10 10s, so we've got 10 in this column, but we need to borrow from that, so that just becomes 9, that becomes 11, and now we can just subtract. 3 from 11 is 8, 1 from 9 is 8, and 0 from 1 is 1, so 188. Now the point is, we can't do that if we are dealing with x terms. So we would have 2x, x equals 10, so let's just, instead of writing 10 squared, we'll write x squared, okay, plus no x's plus 1. And now here we've got, there we go, let's just complete that arrow. We've got no x squareds, we've got 110, so 1x, and we've got 3 here. What would we do? Well, we can't do all this borrowing, so we simply subtract 3 from 1 to give us negative 2. Here we've got an x subtracted from no x, so we've got a negative x. And here we've got an x squared subtracted from 2x, gives us our 1x squared. So what was going on with all this borrowing? Well, let's think about this again. Okay, I erase this. Now you'll remember from an earlier video that we don't have to do all that borrowing, and in fact we can't when we're in algebraic terms, but let's do it conventionally. So 201 subtract 13. So this time 3 from 1 we're going to say is negative 2. Okay, 1 subtract 3 gives us negative 2, so no borrowing this time. And 0 subtract 10 here will give us negative 10, negative 10, and 0 from 2 will give us, sorry, this should have been 2x squared, shouldn't it? That was a mistake there, 0x squared from 2x squared. So exactly the same way, this is 0 hundredths from 200, so it gives us 200. And so what have we got? We've got 200 subtract 12 gives us 188. Similarly here, if we put in x equals 10 into there, we would end up with 200. Here we've just got 10, so subtract 10, and here subtract 2, giving us again the total of 188. So working in conventional numbers and showing you that this borrowing method is peculiar to the decimal methods that we use, that standard algorithm doesn't apply here, hopefully introduces us to what we do with polynomials. Now, let's move over to the left here then and see this in action. So this time, well, let's write that out again. So we've got 2x squared, okay, plus 1. This is our equivalent of 201. 2x squared plus no x's plus 1. And now we're going to subtract. What are we subtracting? We're subtracting x plus 3. X plus 3. Okay, and now we can do this horizontally. Okay, we don't have to use a column method. The problem we've got here is that we're subtracting the x, but we haven't subtracted the 3. So the mistake that people very commonly make when they've got a subtraction of two binomials here is they're subtracting the first term but not the second. Now I'll show you what I mean by putting the parentheses in. Okay, when we're doing it the column method, so if we had 2x squared plus 0x plus 1, and then we put underneath the x has to go here and then 3, then we haven't got a difficulty. We can see we're lined up here, we can see this is minus 2, this is negative x, and this is 2x squared. So the column method works perfectly well, but when we're using a horizontal method, and we will usually be using a horizontal method, then we're going to run into difficulties with this idea of subtracting two terms, a binomial here, or a trinomial, 3 terms. What we have to do is we have to distribute this negative across all the terms within the brackets. Okay, how does this work? So let's rewrite it. 2x squared plus 1, that's our first binomial, so that represents this number here, 201. And I'm going to say subtract 1 times x plus 3 to make this even clearer. In other words, there's a negative 1 outside the brackets, so if we multiply the x by negative 1 and the 3 by negative 1, then we'll have everything correctly expressed. So in other words, we've got 2x squared plus 1. Now we're going to distribute this 1. Okay, so we say minus, well, 1 times x, it's x, so minus x, and minus 1 times the 3 here, so we've got negative 3. We can now drop these brackets, so I'll just erase them, and we just proceed as normal with ordinary addition. Okay, so in other words, what we're doing is gathering like terms. So we say, well, how many x squareds have we got? Just that 1 there. So 2x squared. Now let's erase the underline. Now we say, how many x terms have we got? Well, just 1, but it's a negative x. So we're adding negative x. And now how many 1s have we got? How many constants, if you like? We've got 1, subtract 3, so that's negative 2. Gathering like terms, negative 2. And our final expression then, our answer to this subtraction is 2x squared plus 1 subtract x plus 3 equals 2x squared minus x minus 2. Okay, well, if I went a little fast over that, we're going to do it again, and don't forget, of course, to pause the video and make sure you understand each stage. But what we've done so far is we've run through the kind of theory, the ideas behind this. Now we've got to do is establish the method. So let's choose now something like, let's see if this was A, this was our first problem. Let's have something a bit longer. Let's say we'll use parentheses so we can see what we're doing. 4x squared plus 7x. Let's say subtract 2 within that trinomial. We've got a negative. And then we'll subtract a binomial. So 2x squared, let's say, plus 4. And let's add another one. Well, let's subtract another one. So we'll subtract just a monomial, just one term here. And let's say x cubed. Okay? Right, how would we do that? Well, we can see immediately that we've got to distribute this negative across all the terms in this binomial here. So let's start with that. So we can drop the brackets on this one because there's no subtracting in front of that. So we just say that's 4x squared plus 7x minus 2. Now, though, we've got to distribute. So minus 2x squared minus 4. Okay? And now we don't need the brackets. And finally, minus x cubed. And what we've done here effectively is we've turned a subtraction into an addition, because these negatives here, negative 2, negative 4, negative 2x squared here, and negative x cubed. What we're doing, in fact, is we're adding a negative. Okay, so we're into addition here, which means we can start commuting. So we can say, what are the like terms? Well, we've got x cubed, and we start with the highest power. So we've got x cubed, but it's not x cubed, it's negative x cubed. I'm going to just drop these brackets here so that it's not confusing. So I think we don't need those. That helps us see it a bit clearer. Okay, so start with our x cubes then. Negative x cubed just gets written up front like that. Now we're going to look for our x squared. So we've got 4x squared there, and we've got a negative 2x squared here. So it's 4x squared, add a negative 2x squared if you like, which of course is 4x squared, subtract 2x squared. So 4 subtract 2 gives us 2x squared. So that's our x squared still dealt with. Okay. Now what we'll do is erase these underlines again. And we're looking for x's. So we've got 7x here. And have we got any other x's? I don't think we do. So that's the only x term that we have. So, and it's a positive, so we just write plus 7x. Okay, now we'll erase the underline here. Okay, and underline now just our 1, so finish with our 1s. Now here we've got a -2 and a -4. So what does this mean? -2 subtract 4. In other words, we're going further down into the negatives. -2 minus 4 is -6. Okay, so let's just erase these for neatness. We've completed our term. We now have our result, 4x squared plus 7x minus 2. Subtract this binomial, 2x squared plus 4. Subtract x cubed equals minus x cubed plus 2x squared plus 7x minus 6. So that's basically how we deal with subtraction and with negative terms. We have to make sure that we convert. There's an extra step, if you like. We have to convert any negatives into. We have to, remove the brackets here by distributing that negative, like a -1, multiplying out those brackets, so we're just adding negatives. We end up then with this long string, and then we gather like terms until we simplify the result. We end up with descending powers, and that's our final answer. Okay. Right, so what we've got finally in this video is a visual illustration of what's going on when we subtract. I want to show you the 2 steps that are involved, and I've kept these expressions quite simple so that we can understand them visually using simple terms, and then you can see how it can become a little bit more complex when you start increasing the numbers or changing the signs a little. Anyway, what have we got here? Okay, these tiles represent, if you remember from previous videos, the red tiles here represent simply x, because it's not supposed to be measurable, so that this length here is an unknown length. It's x units long. Okay, it's variable. It could be extremely long indeed, or it could be extremely short. So we can't represent that except by some unknown length that we can't measure. So that's an x. Okay, and these are x's as well. So we're going to subtract 2 x's here from this x here. This is x squared. So whatever that length is, the unknown variable x there, times itself, so multiplied by itself. In other words, this is x times x, x squared. So that's an x squared. We've got another x squared here, and we've got an x squared over here. So we're going to subtract an x squared from 2 x squareds. 2x squared subtract x squared. Okay, up here we've got a 1, so we've just got 1 unit here, and we've got 2 here. So we're going to subtract 2 from 1. Let's write this out conventionally. So we've got 2x squared here, yeah, plus an x. Everything's positive at the moment, and we've got a 1. So it's simply very nice, easy numbers. 2x squared plus x plus 1. We're going to subtract. I'll leave a bit of space here. We're going to subtract another trinomial, quadratic expression, so it's x squared plus 2 x's, so 2x plus 2. But of course we're subtracting the whole thing, so we put parentheses around this polynomial. Okay, now what I'm going to do is show you what happens when we distribute that negative across all of the terms in the parentheses. So we've said that this is like a -1 multiplying throughout, and what will happen is that anything in the brackets here, it'll have its sign reversed. So if this was -2x minus 2, then those would be changed from -2x to +2x and -2 to +2. But because they're all positive, all that's going to happen is that minus sign here, that -1 outside the parentheses, multiplying across will just change everything inside the brackets from positive to negative. Now we can represent that visually like this. All I've done is program this so that it will change its color to show you a negative. So this x squared, let's just get the pen up again. So this x squared will become -x. This x will become a -x, and so will this one, so -2x, and this 2 will become -2. And as I say, we can represent this visually by just changing the color. So that becomes a nice bright pink there to represent -x squared. These will have to change color to their complementary color, so they become green, so -x's. And this, I'm not sure what color this goes. It goes a kind of turquoisey color. Okay, but these represent now -2. So if we now look at these two expressions visually, we can see that this -x squared is going to cancel out, when we join them together, this +x squared. So what we're doing, in other words, is we're adding these two terms together. We're going to add these, and as we bring that across, those two are going to cancel out, those two x squareds. We can also see that this -x here is going to cancel with this +x. It's called a zero principle. X minus x will give us 0, so they just cancel each other out. So what we're doing at this stage of our example, when we're visualizing this, is we're showing what happens when, instead of subtracting, if you like, we're adding, but we're adding negatives. So I'll show you what I mean. What we're going to be doing here is, let's just erase those. Yeah, so if we erase these parentheses, what we've said is that negative is going to make everything in there change its sign, so that we're going to erase those positives, so that this becomes, okay, so -1 times x squared, -x squared. This becomes -2x, and -1 times 2 is, of course, -2. So we've dropped the parentheses, because now what we're doing is we're simply adding. We're adding that to that to that to that to that. We're adding them all together. Okay? Joining them together. And we can do that because we've now changed every term to negative. So it's subtracting, but it's adding negatives. So what we'll be doing is we'll be gathering like terms. So we'll be gathering the x squareds, just as we did before with addition. We'll be gathering the x's. I'll do a double underline here. So we'll be gathering together, we'll be adding x and a -2x. And we'll be adding 1 and -2. Okay? Okay, let's go back to our visual diagram then. So, what we're saying is this negative will go over and join now. It'll be added to this positive, but that will cancel both of them out. So here we go. Let's draw it over, and both are cancelled. If we get our eraser, we can just erase those symbols then. So that -x squared went over here and cancelled that +x squared, leaving us just with x squared. Okay? Now, we can do the same with these. One of those negative x's is going to cancel this +x. So here we go. There we go. And this one here is going to give us not an x here, so that's incorrectly labelled at the moment. Let's just erase these labels over here. What we've got here now is a negative x, representing by this green. So it's no longer red, it's green, so it's a negative x. So what we've got is x squared minus x. And now we've got to complete the job by bringing these over to here. So that one gets cancelled, and we end up with a negative 1. Okay, so erase that label, and this becomes negative 1. Okay, so we've got x squared minus x minus 1. Visually, that's what seems to be our result. Let's see if it works when we actually complete it over here. So we're gathering like terms. So let's keep going horizontally. There we go. So we start with our x squared. 2x squared subtract x squared gives us, well, just x squared, exactly as we have over here. X subtract 2x gives us minus x, exactly as we have here. And 1 subtract 2, if you think of your number line, you're going back to 0, then back one more, minus 1, negative 1. Okay, so what we've done is we've shown here, hopefully visually, I mean obviously we wouldn't normally work in this way, but visually what the ideas are, if you like, that underline what we actually do, the method that we actually use. So the method has 2 steps. The first, as we've seen, is to remove those brackets by distributing that negative across everything within the parentheses. Then we've got a straightforward addition, but we're adding positives and negatives, gathering like terms, and then we get our result.